You know, we see averages literally everywhere. Average salary, average temperature, average test scores. It's always this one single, simple number. But here's the thing. That simplicity, it can be really misleading. What if I told you that the average often hides the most interesting part of the story? Well, today, we're going way beyond that one number to understand the true shape of our data.
So let's kick things off with a real-world problem, right? Imagine this. You're a coach. It's the final seconds of the championship game. You need one player to take that final winning shot. You look at the stats, and your two best players, they have the exact same average score. So, who do you choose? Who's the one you can really count on?
Okay, so here's the actual data behind that average. Player A and player B both average 20 points per game. But just look at how they get there. Player A is like a metronome, always scoring right around that 20-point mark. Player B, on the other hand, is a total roller coaster. You get an amazing game, but you also get a game where they pretty much disappear. It's the same average, but a wildly different story.
Right. So to really tell these players apart, that single number, that average, is just not going to cut it. We need a whole new set of tools that can actually measure the spread or variability in their performance.
And that's where these things called measures of dispersion come in. You can think of it like this. If the average tells you the center of a target, these measures tell you if all the shots are clustered tightly around the bullseye or if they're just scattered all over the board.
All right, let's dive into our new toolkit, and we're going to start with the first and most basic tool. It's fast, it's easy, and it gives you a really quick first impression of what's going on.
This tool? It's called the range. And the calculation couldn't be simpler. You just find the highest value in your data, find the lowest value, and subtract them. It is, without a doubt, the fastest way to get a sense of the total spread.
So let's throw this at our roller coaster player, player B. Their highest score was 35, their lowest was just 5. So 35 minus 5 gives us a range of 30 points. Wow! That one number instantly tells you there's a massive swing in their performance. But, and this is a big but, the range has a huge flaw. Because it only looks at two data points, the absolute highest and the absolute lowest, it ignores everything else in the middle. This means one crazy game, whether it's amazing or terrible, can make a player seem way more inconsistent than they really are.
Okay, so clearly we need something better, something more robust that considers every single data point. And this is where the heavy hitters of statistics come in, variance and its famous partner, standard deviation.
Now, I know this looks a little mathy, but hang with me because the logic here is actually pretty cool. Let's do this for our consistent player, player A. First, we get the mean. We already know that's 20. Then, for each score, we see how far it is from that mean. Step 3, we square those little differences to make them all positive. And finally, step 4, we just average those squared results. And for player A, we get this tiny little variance of 0.67.
And that, right there, is exactly what variance is. It's a single number that tells you the average square distance of every single point from the center. A small variance, like the one we just saw, means the data is packed super tight. A big variance means it's all over the place. Okay, but there's one kind of weird problem here. Our variance for player A was 0.67, but 0.67 times what exactly? Because we squared the points, the units are now squared points. And I have absolutely no idea how you score a squared point in basketball. It's a useful number, for sure, but it's not very easy to wrap your head around. And this, my friends, is where standard deviation swoops in to save the day. It's the perfect fix for our squared points problem. All we do is take the square root of the variance. That's it. That simple step undoes the squaring we did earlier and brings our units right back to normal, understandable points. So for player A, we take the square root of that 0.67 variance, and we get about 0.82. Now we're talking. This is a number that actually makes sense. It tells us that, on average, player A's scores are only about 0.82 points away from their 20-point average. That proves what we saw with our eyes. This player is incredibly consistent. Okay, so standard deviation is awesome, no question. But what happens when you need to compare two totally different things? I'm talking apples and oranges.
Like, how do you compare the volatility of a $14 stock to a $120,000 house? Their standard deviations are going to be in completely different universes. So how can we get a fair comparison?
For this very specific job, we need to pull out a special tool from our kit. It's called the coefficient of variation, or just CV for short. And what it does is brilliant. Instead of looking at the raw spread, it looks at the size of that spread relative to the average. It's basically asking, yeah, the spread is this big, but how big is that compared to the average itself?
And this is where the magic happens. I mean, just look at the raw standard deviations. They're not even in the same ballpark, right? Less than $3 for the stock, but over $15,000 for the house. But the moment we calculate the CV, which is just the standard deviation divided by the mean, the whole story flips. The stock has a CV of over 20%, while the house is down at just 13%.
And that's the bottom line here. A smaller CV always means more consistency. Plain and simple. It doesn't matter what the scale of the numbers is. In this case, it shows us that even with those huge dollar figures, the housing market was actually the more stable, less volatile investment of the two. Pretty cool, huh?
All right, let's pull all of this together. In just the last few minutes, you've basically gotten a brand new data toolkit that lets you see the real story hiding behind any average.
So, in your toolkit now, you've got 4 incredible tools. You've got the range, which is perfect for that quick, back-of-the-napkin look at the spread. Then you've got the super robust variance that uses every single piece of data. We make that intuitive and easy to understand with standard deviation, our most common measure. And finally, you've got the coefficient of variation, our secret weapon for making those fair comparisons between totally different things.
You know, there's this quote that I think just perfectly sums up everything we've talked about today. The average, it's useful, it's convenient, but it's often a fiction. The real story, the truth about consistency, about risk, about reliability, that all lives in the spread.